Hey gang, welcome back to Inverted Pursuits Laboratory. Now, a few weeks ago, I posted a video about my Phoenix rocket exploding mid-flight. I've been trying to, ever since then, determine what caused that explosion mid-flight, what caused it to literally blow itself apart. We were looking at that rocket. I actually only got back the bottom section of the rocket, which I've got here. This is the only piece that came back. It was just my fin can. And if you remember seeing in the rocket, I was just like, I guess there's a hole somewhere in the ground. And unfortunately, I lost a camera and an altimeter with that rocket, the top body sections blowing themselves apart at the fin can joint. But I needed to figure out why that happened. It's been bugging me and I can't let it go. So I've needed to figure out why. So what I ended up doing is I 3D printed another one of the rockets. So this is what the rocket looks like unpainted. Actually, I had to break into some other colored filament, but it looks like this unpainted, and then there's a nose cone section that goes on top. Now, I had already redesigned the 3D printed rocket into a new version that I was going to call that I'm calling Chimera. This rocket had some modifications to it, in particular to how the shock cord mounted, how the engine mounts worked. Like, this is the engine mount I was originally using, just a little 3D printed guy that slides in the back, and you can see there's paint all over it. And the new one was much more robust and had this nice little shock cord mount right here that you could tie your cord around. The old rocket didn't have a shock cord mount. Tried different ways of doing it, like Estes rockets, where you take some paper, fold the string inside of it, glue it all together with some epoxy and CA glue, and then glue that inside the body tube. And that was my entire plan. And I'd already had issues with that not working on 3D Hire, which was my first 3D printed rocket that's up on a shelf. It was basically this rocket minus the top body tube. When I was flying it on lower powered stuff, I literally just flew it in a shorter configuration. I've just been modifying this design as I've gone along. But the big issue was that I'd been having trouble mounting that shock cord. So to get around that in Phoenix, I had printed a little like wedge piece that was part of the diameter of a circle that I bolted a screw through, and I epoxied into the body tube. Now, because I had already assembled and glued the rocket together as I was running into these issues where the body tube wasn't wanting to stay together while I was testing Phoenix, I only ended up gluing like the location like right around here in the rocket, which this is the first body tube section as you're coming down from the nose cone, which meant there was a blockage that sat right here in the rocket. And what I think happened at the last launch is that I was rushing a little bit. We had some wind that was causing rockets to blow a lot, and we had a little lull in the wind, and so I just wanted to get to the pad. And I think that I forgot about that being in there and just packed it like a normal rocket. I did have to modify the packing method because I was concerned about the parachute not deploying. What I had never considered is that the parachute not deploying meant the rocket would quite literally blow itself in half. So what I think happened is that little piece basically clogged the rocket up once the parachute was put in there, and then resulted in the rocket, once it reached the point where the ejection charge went off from the motor, just blew itself apart. The upper section went and nosedived into the ground, and this fluttered back down in a slow, controlled manner that I was able to find it. But I still didn't have proof that that's what happened. We can go look at the launch footage. Unfortunately, it's really hard to see. It was about 1,500 to 2,000 feet in the air when the ejection charge went off, so it's just very hard to analyze the video footage. So I decided that I needed to test my theory and test that that's what I thought it was. So I decided I was going to go ahead and 3D print another of Phoenix, which is what I did here. I 3D printed this. Now, I had some issues in the 3D print where it didn't want to stay together quite as well. And so I went ahead and duct taped, I packing taped all the sections together, and I packed it without that. I used my new designed launch mount, or motor mount with the shock cord attachment. So I decided first off, I wanted to try that, see what happens, see if I can make the rocket behave and actually deploy the parachute and do it all correctly. And so I packed like half a gram of black powder into a little pill capsule, and put the rocket together and took it out to my backyard to do an ejection test. So let's take a look at how that went. Chimera ejection test 1. System armed in 5, 4, 3, 2, 1.
That was funny.
Dang, those things just do not have enough poop. Okay, so obviously that first ejection test failed spectacularly. It was not what I hoped for, not even remotely. Nothing actually came apart, nothing happened. It just looked like everything went the wrong way. So I decided, let's just go big or go home, and I packed 1.5 grams of black powder into an old spent motor. So I literally took this old motor here, which is a 24 millimeter F44 by Economax, and I packed 1.5 grams of black powder in here and put tape over it and ran a fuse out the motor spot so that I literally could just hook my controller up to it and then blow the ejection charge like it was a normal motor in there. So then the back was plugged and everything was plugged up properly. And honestly, I was like, yeah, this could just blow the rocket apart. I had no clue if this was going to work. So let's just take a look at that footage real quick. Chimera ejection test number 2 after it. All right, battery live.
Also, your nose cone is kind of like already falling off.
System live, it's fine. All right, in 5, 4, 3, 2, 1.
Hey, that was good.
I'd say it works.
That was good.
Yeah. System safe.
Let's go check the damage.
So with that, we can see that the ejection test went off perfectly. Once I had enough black powder in there to separate everything, get the pressure up high enough, it actually had so much force it tried to drag the rocket with it, which that's a good thing. A little too much force is better than a little too little. I was impressed that it didn't shear the shock cord, didn't break any of this. I did a full analysis of this rocket where I looked through every piece, and like nothing's really all that burnt in there. Like it really looks great. Like the rocket did everything perfectly with my new design, which gives me confidence that the new rocket Chimera is going to work beautifully once I 3D print a new one. I'm not using this one I ejection tested on a 3D printer and get it ready for flight. But is that enough to say that the reason my rocket blew apart was because of my old mounting method? In my opinion, yes. The only reason I say yes is because I've flown so many rockets in the past. Now, I've flown a number of hobby rockets when I was younger, and I had a common issue whenever I got in a rush that if I didn't take my time and make sure the parachute was packed properly, the parachute never deployed. It happens. If you pack a parachute too tight, the parachute actually won't come out. If the parachute doesn't just slide smoothly into the body tube, the probability of it coming back out is not very high. Not high at all. I've got numerous rockets that I have nosedived straight into the ground and recovered their very crumpled remains. I mean, I was amazed this wasn't a nosedive straight off. It actually like blew itself in half, but it was a 29 millimeter motor I flew on. It wasn't an 18 millimeter Estes motor. It was a 29 millimeter Aerotech motor. It had a lot more force behind it when that ejection charge went off. So it blowing itself apart is not out of the question. So, in my opinion, I can conclusively state that the reason my rocket actually blew itself up was because of that shock cord mount that I had designed, which I wish I had one of. I only ever printed one and put it in the rocket that I don't have. But the fix going forward is going to be this redesigned motor mount tube. And we will see Chimera fly here in the future. But in an upcoming video, I will have the entire assembly process for Chimera and how I went about designing that rocket in some detail. Thanks for watching, gang. Now, before I leave you, I wanted to tell you about something cool I'm in the process of doing. So I recently launched a web store on my website. It's linked in the description below. Now, currently I've only got 3 products on there, and they all are only STL files. So there's no actual product. You still need a printer to go and 3D print these files. But what I have available on there is a pack of nose cones. It comes with 6 different style nose cones that you can 3D print, all the way from small Estes BT20, like what flies on the High Flyer, all the way up to a 38 millimeter nose cone like this that flies on my Chimera rocket. I also have things like camera housing. This is a camera housing that's designed to hold the Estes Astrocam camera that comes with the Astrocam rocket. And so it just sits right in here, and then this little cover screws on top. And the last product I have is actually for the T3 tracker. So it's a little box that the T3 tracker, its battery, and a little switch that I've added to the whole system mount into. And then you can mount this onto a tripod. It allows for easy control of your tracking system while you are out and about at the launch site. So if you're interested in taking a look at any of those products, they are linked in the description below. See you in the next video, gang.